Hi, I'm Dr. Musil, and in this video we're going to be discussing the four basic truth functional symbols in more detail so that hopefully you start to become more familiar and comfortable, familiar with them and comfortable using them. So we'll follow the order that the authors use in terms of going through these. So we'll start with negation, which is the simplest of the four symbols, and then we'll end with the conditional, which is by far, in my opinion, the most difficult of the four basic ones. Okay, so we'll start with negation. Remember, these are symbols that are representing something that's being said, the logical relationship that's involved, right? Or as I sometimes like to say, it's a logical operation that's being involved. So negation is just represented with this sign, right? Or, as I mentioned in the last video, you can use this sign. So that's the sign for negation. So let's say our basic claim variable was P, right, for Paul will go, and what's actually being said is Paul won't go, right? Well, we represent that very simply with not P, right, or it's not the case that P, okay? Now, the truth table involved, it's very simple here. So if we just are dealing with one claim variable, right, we would only have two possibilities. Either the basic claim variable, right, or basic claim is true, Paul goes is true, or it's false, Paul goes is false, right? And when it comes to the truth value of the negation, okay, it's always just going to be the opposite of whatever the original claim was, right? So let's say Paul goes is true, well then it's not the case that Paul goes is going to be false, right? Because Paul goes was true. On the other hand, if Paul goes is false, or Paul will go is false, right, then it's not the case that Paul will go. Well, that's actually true, right? Now, of course, it can get more convoluted and involved if we throw in different symbols or different claims and different symbols. So Rachel goes, right? Maybe what we're dealing with is something like Paul won't go, but Rachel will, right? So that's what that's going to look like. Paul won't go, but Rachel will, right? So how are we going to get that in a truth table? Well, now, right, we have two claim variables. So as we learned in our last video, how many rows are we going to need? 4, right? So our reference column depicting our two basic claim variables will always go on the far left, no matter what. All right, and I, again, would encourage you to always be as neat as possible. Okay, so again, start on the far left, true, true, false, false, and then every other. Okay, and now we're in a position then to work with the negation, right? So it could be involved, the whole point here is it could be involved in a more complex statement, right? But before you can depict, right, the negation part itself, you still got to deal with all the reference columns, right, or the basic claim variables before you can then get to the negation. So in this case, we'll have 4 rows under that negation column, right, because given how many claim variables we had, it dictated that we'll have 4 rows, right? So again, it's always going to correspond to the truth value of regular P, right? So if Paul goes, then it's not the case that Paul goes will be false every time P is true, right? And if Paul goes is false, every time that's the case, then it's not the case that Paul goes will be true. Okay, so that's the gist of negation, what it looks like in terms of its symbol, and how you would go about then getting that into a truth table. Okay, let's go ahead and move on to our next one. So this one is conjunction. So the first thing I should mention is both things listed. So the symbol, again, I'm going to use that instead of the ampersand because as you saw in the last video, I have trouble drawing the ampersand. The thing in the middle separates the two different distinct things that are thought to be true, right, or suggested to be true. And those are called conjuncts. So we have the left conjunct and the right conjunct. Okay. So, for example, Joe will drink water. Well, Here, let me change these because I have a certain example on my sheet here. J and S. So J will stand for Joe will drink, terrible handwriting there, water. And S will be Sue will drink juice. Okay. Two distinct things, right, are involved in this. So the statement is Joe will drink water and Sue will drink juice. Okay. There's two distinct claims involved there, right? On the one hand, it's being asserted that Joe will drink water and Sue will drink juice. Okay. Now, when is that compound claim, that more complex claim overall, right? This whole thing, when is that going to be true and when is it going to be false? Well, you want to remember this shorthand, right? It's going to be true if and only if both conjuncts are true, right? So provided either one is false, right, or both are false, then the whole thing's going to be false, right? So if Joe's not going to drink water, then the whole statement is going to be false, right? Whoever's saying Joe will drink water and Sue will drink juice, right, that overall statement's false, right, because one of the things suggested was false, okay? Or if Sue's not going to drink juice, sure, Joe will drink water, but Sue's not going to drink juice, well, then again, the whole thing is considered false. Okay, so all it takes is for one of the conjuncts to be false and the whole conjunction, right, is then false. Okay, so when is the whole conjunction true? If and only if both conjuncts are true. Okay, so then how will this look in a truth table? So we start with our reference columns on the far left. Represent all possible combinations of truth values, right? It could be the case that both of these are the case, right? Both Joe did drink water, that's true, and Sue will drink juice, that's also true. Or it could be the case that Joe will drink water, but it's false that Sue will drink juice. Or it could be the case that it's false that Joe will drink water, but true that Sue will drink juice. Or it could be the case that both are false, right? Neither Joe will drink water, that's false, and so is Sue will drink juice, that's also false, right? So again, we've represented every possible combination of truth values for those more basic parts, okay? And so once we've done that, then we're in a position to, right, to pick the truth value of the more complicated, right, claim, the more compound claim, or how do you put that, the compound claim, okay? J and S, okay? So we've got all the parts involved here, so we're in a position now to map out the truth value of this because we've already got all the more basic parts, right? Both conjuncts are already depicted here. So again, when is this conjunction going to be true? If and only if both J and S are true. So in this first row, oh, it's true because they're both true. But in every other row, one or more of the conjuncts are false. So every other one is going to be false. Okay. So as long as one of those two parts is false, the whole thing is going to be false. Okay. So that's a conjunction. Next up, I think fairly easy, very similar to a conjunction, although kind of in reverse almost, would be a disjunction. So let's see. So the way you represent a disjunction is with the symbol, the small v is kind of what I call it, whatever you want to call this symbol here. All right, so again, you're using basic claim variables. And there's going to be two disjuncts. The things on the left and right are referred to as the left and right disjuncts. So just like in conjunction, you have those two constituent parts on both sides of the conjunction symbol. Those are referred to as conjuncts. Well, here in a disjunction, these two parts are referred to as disjuncts. Okay. So now, when will these two disjuncts, or when will the disjunction as a whole be true? Well, actually, we have an easier, the easier way to sort of remember its truth value is in kind of reverse, right? It'll be false if and only if both of these are false, okay? Right, so it can only be false, the disjunction as a whole, if both J and B, right, are false. Otherwise, as long as one of these is true, then the whole thing is true, okay? So what's my example here? Joe or Bob will go. Okay, so J represents Joe will go, right? And B represents Bob will go. Okay. So how does that look like in the truth table? Again, we start by putting up our reference columns for our basic claims, J and B. Always looks the same in a two-claim statement, right? Or two-claim expression, right? When two claims are involved, it's always going to be 4 rows, right? And so the far left one's always going to be true, true, false, false. And the one on the right is going to be true, false, true, false. Okay. Now we're already in a position then to determine the truth value of the disjunction as a whole. Remember, as long as one of them is the case, right, then the expression, right, as a whole is going to be true, because all they're saying is, look, one of them will go, right? Joe or Bob will go. So as long as Joe goes, or Bob goes, or they both go, right, what they said as a whole is true, okay? To say that what they said is false, neither Joe nor Bob go, right? Otherwise, right, as long as one of them goes or both of them go, then what they're saying is true, right? So look, in this first scenario, Joe goes and Bob goes. So the expression Joe or Bob goes is true. In this case, right, this scenario, scenario 2 here, row 2, Joe goes but Bob doesn't. Well, the expression Joe or Bob will go is still true, right, because Joe went. Joe doesn't go in this one, but Bob does. Well, Joe or Bob will go is true because Bob went. And then in the fourth row, right, we have a scenario where neither Joe or Bob goes, right? And they told us Joe or Bob will go, so they're lying in that scenario, right? Neither one went, so the disjunction as a whole would be false. So that's disjunction. Fairly straightforward, I think. And then we get to the one that's, in my opinion, by far, and I think the authors suggested this as well, by far the most difficult for rookies in logic, and that's dealing with what's known as the conditional. So the symbol here is an arrow pointing this way, and make sure you're pointing the correct way. Okay. What's my example here? Yes. All right. If Joe goes, Sue will go. So let me write that up here. If Joe goes, Sue will go. Okay. So J will stand for Joe goes, and S will stand for Sue goes. Okay. When is a conditional false? It's actually true far more often than it's false. The only time a conditional is false, it's false if and only if the antecedent is true and the consequent is false. So I mentioned a couple fancy words there, right? The antecedent of a conditional is always the first thing, before the thing preceding the arrow, and the consequent is the thing to the right or that follows the conditional arrow. Okay, so you just got to commit those terms to memory, antecedent and consequent. Okay, so again, when is the conditional, the thing being expressed as a whole, right? When is that going to be false? If and only if the antecedent is true and the consequent is false. Okay, so when is if Joe goes, Sue will go false? It's only false if Joe goes and Sue doesn't, right? Because you should kind of, and I'll try to express a better example here in a moment to capture this point, but think of it as if, when can you say you're a liar? What you said was false. You made a false promise. Well, it's only if what they said had to happen for this to happen happened, and then this still didn't happen, right? Okay, so they didn't say anything about what would happen if Joe doesn't go, right? So if this is false, right, the whole thing is still thought of as being true, right? Because you can't say you're a liar, right, if this doesn't happen, if this is false. The only time you can say you're a liar is if this is true, and then this, nevertheless, is still false. Okay. So I like to put it in terms of my example. I think is if I win the lottery, then I'll give you $1 million, right? You can't call me a liar if I don't win the lottery, right? I only made a promise. I only suggested that if I won the lottery, then I'd give you $1 million, right? So you can't point to me and call me a liar if I don't win the lottery, right? So that whole statement if I win the lottery, then I'll give you $1 million, is only false if I win the lottery, right, and then I don't give you $1 million. So as long as if I win the lottery and I still give you $1 million, well, then it's still true as well, right? The only time it's going to be false, you can say you're a liar, you lied to me, is if I won the lottery and then did not give you the $1 million. Okay. All right, so let's see what the truth table looks like for this. So again, we start with our reference columns on the far left. Hopefully this is becoming second nature for you now. Practice, practice, practice. I sound like a broken record, but that's really the case, especially with these two tricky chapters, chapters 8 and 9. The more you practice them, the easier it will become. So there's every possible combination of truth values for the more basic parts involved in what's said, right? Joe can go and Sue will go. Joe will go, but Sue won't go. Joe won't go, but Sue will go, or neither one of them will go, right? And so now we want to analyze when the expression, if Joe goes, Sue will go, right, as a whole is true or when it's false, right? So we will then label J, if J, then S. And you would read it that way, if J, then S, okay? So again, when is the conditional false? If and only if the antecedent is true and the consequent is false, right? So here the antecedent is true, but look, the consequent is also true, so the conditional will be true. Here we have a case where the antecedent is true and the consequent is false. So here's an example of where it would be false, right? They made a promise that if J is the case, S will be the case, and it didn't happen, right? Now remember what we said, as long as the antecedent is false, the conditional as a whole will always be true, right? Because you can't say you're a liar when what they said had to happen for the other thing to happen didn't happen in the first place, right? So if J is false, the conditional as a whole is still rendered true from a logical perspective. Okay. So that is the truth table for your basic conditional. Okay. And now I'll throw at you a little bonus truth functional symbol here. And they fleetingly mentioned it in the textbook as well. It's what's referred to as a biconditional. And it's not as tricky as it sounds or as it looks, okay? So let's see, what's my example? So it'll look something like this. Okay, a double-sided arrow, right? In our normal conditional, right, it's just pointing this way, but a biconditional, you have the arrow going both ways. Now, I don't remember them showing you to symbolize it that way in the textbook. How they symbolized it was this, and this works equally as well, right? You'd have if J, then S, and if S, then J, right? Because it is basically conditional going both ways, hence biconditional. Okay, so it would be Joe. If we go, it'll sound something like this: Joe will go if and only if Sue will go. Okay, so the key expression here is if and only if, right? So the best way to sort of see how this is working, the logic in here is working, is to read it one at a time with just if and then only if, and you'll see why both of these are implied in what's said here. So Joe will go if Sue will go, right? So if Sue goes, that's basically saying if Sue goes, Joe will go, right? Now the only if, right? Joe will go only if Sue will go. So that's telling us, look, if Joe went, then Sue had to have gone, right? So that's this one, right? When you read it, Joe will go only if Sue will go, that's implying this one, right? Whereas if you read it, Joe will go if Sue will go, that's implying this one. Okay. So again, that is the part of what's being said that indicates the biconditional relationship involved. Okay. So let's go ahead and put this up on a truth table. This is going to be true if and only if P and Q have the exact same truth value. And we'll see there's two instances where that's going to be the case. So again, when is a biconditional true? If and only if both parts of the biconditional have the same truth value, whether they're both true or whether they're both false, then the biconditional as a whole will be true. Okay, so let's see how that works here. So once again, this is always the same for two claim variables. Okay. Now let's go ahead and put it up this way, okay? Since that's the way they do it in the textbook. So we have on the one hand if J then S. Okay. When is this conditional false, right? When is a conditional false? If and only if the antecedent is true and the consequent is false. So here the antecedent is true, but the consequent is also true, so that's true. This time the antecedent is true and the consequent is false, so the conditional is false. Right? And remember, anytime the antecedent is false in a conditional, the conditional itself is always true. Okay? Now we need this one, if S then J. Whoops. Okay. So same sort of thing, but the reverse relationship, right? So S is the antecedent, and that's true. J is also true, so the conditional will be true. Here the S is false, so the conditional as a whole is going to be true. Here we have an instance where the antecedent is true and the consequence false, so the conditional will be false there. And then finally, the antecedent in this last row, right? The antecedent is false, so we automatically know. We don't even have to look at the consequent. When we know the antecedent is false, we know the conditional as a whole is true. And now we're finally in a position to assess, right, the truth values of the biconditional based on all the possible combinations of truth values here, right? So we have, again, if J then S, and if S then J. So now what we're analyzing is, in essence, a conjunction, right? So when is it the case that both this and this are true, right? Because a conjunction is true when both of its conjuncts are true. Well, in this first row, it's true, right? They're both true. This one's not the case. This one, it's not the case. And in this one, they're both true, right? So if you go back, like I was saying earlier, look what happened. In both scenarios where the biconditional conjunction, or the conjunction that we're assessing, right, where that was true was when both the claim variables had the same truth value, just like I started off saying, right? In this first scenario, the first row, they're both true, okay? So the biconditional as a whole is true. And then in this scenario, in the fourth row, they're both false, so the biconditional as a whole is still true, because, again, anytime the claim variables, right, have the same truth value, the biconditional will then have a truth value of true. Right, so hopefully that kind of made sense. Don't worry so much about the biconditional. We'll be working far less with that. Then, the ones you'll really want to be comfortable with are the four basic ones: negation, conjunction, disjunction, and conditional. Okay, so hopefully this video helped, and we'll go ahead and move on to symbolizing compound claims in the next video.